Hey everyone, welcome to my talk. My name is Alejandro, I'm from the Blue Toxicology Lab, and today I'll be speaking to you about issues surrounding hydraulic fracturing legacy wells and environmental spills. But before I can get into that, I first need to tell you a little bit about the process of hydraulic fracturing. Hydraulic fracturing, or fracking as it is more commonly known, is an industrial practice in the oil and gas industry where chemicals are injected into the ground under high heat and pressure to fracture rock and obtain oil and gas reserves. Following days, weeks, or even months later, the injection fluid will return to the surface containing a complex mixture of both the injection fluid and novel compounds. We call this mixture flowback and produced water, or FPW for short. FPW is a complex chemical mixture made up of organics such as polycyclic aromatic hydrocarbons, metals such as lead and nickel, and salts such as sodium chloride. After this fluid has been reused and fully saturated, it is transported via pipeline or truck to disposal wells to be left in the ground indefinitely. However, transportation often comes with mishaps, and these unfortunately occur in the form of spills. In 2015 alone, over 113 spills were documented in Alberta, and with Alberta's economy so reliant on oil and gas, these type of spills are a constant concern. Thus, it is in every Albertan's best interest to know what happens to spilled FPW, and what will the long-term effects on our environment be? This is where FPW degradation comes in. While it's known that the salts and metals in FPW do not degrade, the organics in it do, with varying rates of increasing and decreasing toxicity as time goes on. To study how degradation affects the toxicity of FPW, we performed LC50s, which is a common practice in toxicology to assess the mortality of a population. Essentially, the higher the LC50 value, the less toxic it is. We used Daphnia magna, the adorable little water bug you see there, as our test species, as they play important roles as a keystone species in the aquatic environment, and they are found all over North America. We performed our LC50s on less than 24-hour-old Daphnia by exposing them to FPW for 48 hours, and repeating these experiments over the course of multiple weeks, all while tracking the organic content. Initial results from these experiments indicate a slow but steady trend towards a higher LC50 value, which indicates a lower toxicity over time. This data provides a proxy to the degradation of FPW, and while not statistically significant yet, could provide insight into what occurs to unclean spills and FPW left in wells or the environment for many years. A lower toxicity also provides the hope that the treatment of FPW may be possible, and in doing so, return millions of liters of water back into the environment, unpolluted and clean. Thank you for your time.